Hi everyone, thanks for joining. So there was a power outage in my area. The entire building is down. So thanks for coming back, even though class was very abruptly ended. We left off doing this product rule problem up here that involved two chain rules, right? When I took the derivative of f of 4x, that involved a chain. And when I took the derivative of g of x squared minus 8, that involved a chain as well. We then used the graph to answer our questions. So what I want to do before we move on to the next problem is talk about these cases. If I have g prime of 6 and you're asked to find that, look at where 6 is. And if I said find g of 6, that would be the value. The answer to that would simply be the height of the graph, which is 3. But if I want g prime of 6, that's indicating the derivative, aka the slope. And notice that at this point, you have two different slopes. On the left-hand side, your slope is 0 because it's a flat line. And on the right side, the slope is, well, down 1 over 2. It's negative a half. So when you have a left-hand slope that's different from the right-hand slope, or your left-hand derivative is different from the right-hand derivative, your slope does not exist. So when your slopes don't agree at a point, it does not exist. Let's look at f prime of 7. Try this one yourself. So we go to x equals 7, and I want the prime, so therefore I want the slope. And again, notice the left-hand slope is negative, the right-hand slope is positive, therefore the slope doesn't exist. So what you're learning is that at sharp corners, the derivative does not exist, because it implies that there's a different slope on the left than there is on the right. Let's do one final example. Let's say I wanted g prime of 5. Try this one yourself. There's 5. What's the derivative, or what's the slope here? The slope of any flat line, you should know, is 0. Slope of any flat line is 0. So you're learning that as well. So for flat, by flat I mean horizontal lines, the slope always equals 0. These are two important characteristics to be familiar with. Sharp corners, the slope doesn't exist. Flat line, the slope is 0. Okay, let's continue though our work with number 4. Now number 4 is a good problem. It's a little bit tricky. It says, find the equation of the tangent line to this expression. Ooh, if I have an expression, what are we missing? We're missing a left-hand side. Write it in, y equals. Now we have a left-hand side. They want the equation of the tangent line at x equals 5. So they're asking, notice, not for the slope, not for the derivative, but for the equation of the line. Anytime I want the equation, I know I need two things. I need a point, and I need a slope. So let's go about finding our point first. I need an x value, that's what's given. And then for my y value, I'll just see what happens when I plug in 5 into this expression. So we'll write down y of 5. Underneath it, let's actually find y of 5. Plugging it in here, and here I get f of 5 over g of, well, 3 times 5 is 15, minus 6 is 9. And now I'll need to use the graph. There's nothing more I can do. I need to go to the graph here. So f of 5 is just the value. Notice there's no prime, so we want just the height. F of 5 is 6, and g of 9 is 1.5, so we're going to write that as 3/2. And to divide fractions, we multiply by the reciprocal, so 6 times 2 over 3. Multiplying across, I get 12 over 3, which is 4. So that's our point. Cross out the y of 5, write 4. Great, now we're going to find the slope. So for our slope, we want to find the derivative. We'll write y prime equals. And notice that we're finding the slope of a quotient. There's a division symbol here, so we'll use the quotient rule. Low, copy down the bottom. D high, the derivative of the top is just f prime of x. Nothing fancy there. It's just f of x. No chain rule. So low d high minus, now I need high, and the derivative of the bottom. Well, the bottom involves the chain rule because I have an outside function, which is g. I don't know what it is. And then my inside function is this linear expression. So to take my d low, we'll use a chain rule. Derivative of the outside, inside stays fixed, 3x minus 6. Not done. Now we multiply by the derivative of the inside. Check your work. All over low squared. So the entire bottom expression, exactly as it is, squared. Great. That's our slope at any x value, but we want the slope at x equals 5. So we're going to plug in 5 now. Plugging it in to my expression, I see this is g of, hey, we already found 3x minus 6 to be 9 earlier, right? 9. So it's g of 9 times, and that's f prime of 5. Don't forget the prime, that's a common error. Minus f of 5 times g prime of 9 again, times 3, all over. Again, g of 3x minus 6, we already know that's 9. So shortcut, it will always be the same for these rules. Sorry, not 9 squared. I meant g of 9 squared. So if I plug in, I get g of 9, and I'll square that. Okay. From here, we're stuck. Now we need to actually use our graph. So let's find each of these carefully. G of 9. That's 3/2 from the graph. F prime of 5. Now careful. Now we want the slope at 5. So pick any 2 points along this. Looks like it's a nice easy slope of -1. Bring over the minus sign. Now f of 5, now I want the value, which is 6. And finish this rest part of this part, try it yourself. Look up just to check your work. G prime of 9. So we want the slope or the value. It says G prime. Try it yourself. Check your work when you're confidently done. And then the bottom, we want G of 9. And we're going to square it. So again, looks like we ended up with that. Now you can finish the rest yourself, but I'm going to leave it here. Actually, no. I actually need to finish this because we want the equation of the line. So let's finish our work up here, say. Okay, so 3/2 times -1, that's -3/2 minus. Okay, well I have a -6 times a -1/2, so that'll be a plus. Half of 6 is 3, times 3 is 9. All over 3/2 squared, well 3 squared is 9, and 2 squared is 4. So on the top we'll use the fraction trick. 2 times 9, 18, minus 3 is, don't forget the denominator. And to divide fractions, we'll multiply by the reciprocal, very carefully. And we have some cancellations we can do. Dividing 15 by 3 and 9 by 3. And continue the cancellations yourself. So for the slope, I got 10/3. By the way, if I'm going quickly, pause the video and really do try it yourself. But we haven't answered the question yet. They want the equation of the tangent line. So in our last step, we're plugging it into our formula. Y minus my y value, that's for my point, equals m, that's my slope, x minus x. Y minus y1 equals mx minus x1, and we're done. You don't have to distribute or anything. We're good to go. Let's try a similar problem. Let me just recap what we did. It said find the equation of the line, so I immediately knew I needed to find the point and the slope. And then it says to this expression without a left-hand side. So I gave it a left-hand side, y equals. And so when I went to find the slope, I knew I needed to use the quotient rule because I have a function divided by a function. Now, when I was taking the derivative of the bottom, that involved a chain rule as well. So hence we did g prime of 3x minus 6 times the derivative of the inside. That is where students make their most mistakes. We plugged in x equals 5 then to get the slope, which was 10/3, and we used our point and our slope in our formula to answer the question. Let's see if we can do another problem. This one's slightly easier. Okay, it says write the equation of the line to this expression at x equals 2. So what two things do we need to find first? Try it yourself. We need the point. Okay, we know the x value. Write it down. And we need to find the y value. So write y of 2. By the way, this guy is missing a left side. So write y equals. That way it's clear. Let's go ahead and find our point right now. So we're not doing anything clever yet. We're just plugging in 2 exactly as we see it. And so in case you've forgotten, for these composite functions, find the inside expression first. So f of 2, using our graph, is 7. The height is 7. So if f of 2 is just 7, then g of f of 2 is just g of 7. Now let's go find what g of 7 is. That's 7. G of 7 looks to be about 2.5. So g of 7, let's call it 5/2, 2.5. And so we got our x, we got our y. Now we just need our slope. So for our slope, we're finding y prime. Now look at the expression. G is not being multiplied by f. If it was the product rule, it would have looked like that, side by side. Instead, f finds itself inside of g. Therefore, we should use the chain rule. So carefully, we'll take the derivative of the outside first. Leave the inside the same. Last step times the derivative of the inside. Okay, that chain rule formula should be like clockwork. Okay, very rapid. Derivative of the outside, inside the same, then times the derivative of the inside. So now we're going to plug in what? Well, we want the slope at x equals 2, so let's find y prime of 2. We're not doing anything fancy here, just plugging in 2 everywhere we see an x. And now we will start using our graph. So starting on the inside, I can find f of 2 first. F of 2 we found earlier is just 7. Now that I know that's 7, I can now find g prime of 7. G prime of 7. So I don't want the value, I want the slope. So I'll pick this point and this point, negative 1/2, which matches, right? We actually already found out negative 1/2 earlier. And now I need f prime of 2. So the slope looks like it's rise over run 1 over 1. So my final slope is just negative 1/2. We're not done. We found a point. We found a slope. Now we should use our formula. Y minus y1 equals m, which is negative 1/2, x minus x. Ta-da! Okay. Pause, review the work we've done so far. Okay, we're going to do the last problem of this kind. Let's do the easier version, just because the more complicated one doesn't really come up as often on the AP exam. So let's do this one. Okay, it says find the equation of the tangent line. So try this one on your own. I see equation. What two things do I need? Go ahead and start finding your point. If there's a left-hand side missing, you need to write it in so that you have symbols to use. Look down, find the y value that goes with x of 1. So you're just going to plug it in to the expression. So g of 2 times 1 is 2 plus 1 is 3. That's the furthest we can go. Now we need to use the table. F of 1 times g of 3. So what did we get for our y value? Check if you got 20. Make sure to replace it up here. So we found our y value. Now we found our point. Now we should find what? What notation will we use? Make sure you write y prime. Okay, well, we need to take the derivative of this expression. What rule should we use? What do you see is happening? What operation is occurring right here? Yes, they're being multiplied. So we use a product rule. Copy the first one. Derivative of the second. Careful. What rule will we use now while we're finding the derivative of the second? Chain. There's an outside, which is g, and an inside, 2x plus 1. So careful. Hold the inside the same. Then multiplied by its derivative. Okay, we did the first half of the product rule. Next, we write plus. We copy the second times the derivative of the first. There's no chain rule here because it's just f of x. Just f prime of x. All over low. Oh, wait, no, I'm thinking of the quotient rule. Okay, product rule. So it's left d right plus right d left. Good to go. What do we do next? We want the slope at x equals 1. So we're plugging in 1 everywhere. We can do some math. G of 2 times 1 plus 1 is just 3, so write it immediately. Don't forget to bring down the primes, these guys. It will throw your answer off if you forget to write them down. We've reached the point where we need our table, so let's find f of 1. Let's find g prime of 3. Ooh, so we're going to use this column now, g prime of 3. Don't forget the times 2 at the end. Now we need g of 3, which is 4, and f prime of 1. Find it yourself. Okay, let's finish. That's 10 minus 4. And so we found a slope, y prime, is 6. Last step, we found our point, we found our slope. Write your final answer. And we're done. Check that your work aligns with mine. Okay. So, today we learned the chain rule. We learned how to use function notation to do product rules and quotient rules with chain rules inside of them. So there was a lot going on today. Well done. That concludes the first half of our lesson. For the next 20 minutes, we're going to learn one last concept. Okay. So actually, let me show you number 7. Okay, so for the last few problems, they didn't give us f and they didn't give us g. We just were told this information, right? Because we had tables and graphs. Now, though, we have the functions. So we will still continue as always. We give a left-hand side, and we want to find the derivative. Nice. That's easier. I just need to find y prime. So proceed as always. Y prime will be, what rule will we use here? G is inside of f. So it's chain rule. Derivative of the outside. Inside guy stays the same. Times the derivative of the inside. Okay, and we want to find the derivative at that point. So next step, plug in 2 pi over 3. Notice I haven't even touched these yet because it will get more complicated if you try to plug them into each other. Save it till the end. So we're finding f prime of g 2 pi over 3 times g prime of 2 pi over 3. Okay, now we've done as much as we can with our symbols. This is now where we will go and we can find the inside guy first. So g of 2 pi over 3, I can find that just by plugging it in. So let's write that down, show our work. G of 2 pi over 3 is the same as 2 cosine 2 pi over 3. Let's quickly graph. Pi over 3 is 60 times 2, 120, so somewhere in this quadrant. The reference angle will match what we circled, so it's 60. Quickly label your sides. And the cosine formula is x over r. So I need 2 times, and the cosine is x over r, so negative 1/2. Therefore, my final answer here is negative 1. That's g of 2 pi over 3. Cross it out, write -1. Now we need to find f prime of -1. So what should we find first? If I want f prime of -1, first we should find f prime of x. Well, that's straightforward, just a power rule. So that's 3x squared minus 6x. And now we can plug in -1. So that will be 3 plus 6, 9. Great. So what did we get so far? So far, we reached the place where we need to just plug stuff in. We got, let me write this a little neater. We found out that g of 2 pi over 3 was just -1. And then plugging that into f prime, we found f prime of x. Plugging in -1, we got 9. Now we need to, so we got the left side. Now we need to do g prime of 2 pi over 3. So what should we find first? Yes, we should find g prime of x first. Well, if g of x is 2 cosine x, g prime of x will be 2 times negative sine x, or -2 sine x. Let's plug in 2 pi over 3 now. Ooh, good news. We already drew the graph. So the sine formula is y over r. So our final answer, negative radical 3. So I know g prime of 2 pi over 3, bringing it back, is negative radical 3. So our final answer is -9 radical 3. That is the derivative of f of g of x at 2 pi over 3. All right, so we're going to skip 8. We're going to skip 9 in the interest of time. You can do them if you'd like and ask me questions. Okay, last section of the day is something called the tangent line approximation. Now, the tangent line approximation says this. I'll give you actually 30 seconds or pause the video to copy this down. So the tangent line approximation basically says that if you're given any curve, like this blue curve here, you can, if you wanted to, let's say, approximate a value close to A. Okay, like let's say I wanted to approximate this value, okay? You can use the tangent line to that curve to approximate the value of the curve. So if I wanted to find out what is the value of B on the curve, I can just plug in B into my line and I'll get an answer that's pretty dang close, right? These points aren't too far off from each other if you use a good line. Now clearly, the further away I move B from my point of tangency, the worse off my approximation. But the closer in I move, so if instead of being over here, I want to approximate, let's say, that value, by plugging it into the line there, they're almost on top of each other. So the closer that the value you're approximating is to the value at which you have your tangent line anchored, then the better your approximation. So here are the steps. First, you'll find the equation of the tangent line at x equals a. So you're basically given a curve, the blue line, and you're going to find a point and its slope, and you're going to give me the equation of the green line. That's what we've been doing using this formula. Once you have the equation of that tangent line, the green one, you will then plug in your b value or whatever x value they're asking you to approximate. And when you plug it in, you're going to get the value on the line. but that will be a pretty good approximation of the true value. So you're going to plug in x to the tangent line to approximate the true value. And that's what we're doing in the next few problems, is we're finding approximations. So I'll show you how it goes. For number 12, it says, find the tangent line approximation to this value at x equals 7. So notice that if I want the true value at 7, I'll have to plug it in like this. 3 times 7 minus 5. Oh, I'm so sorry. Sorry. We could figure out that. That's easy. Because that would have been 21 minus 5, square root of 16, which is 4. But no, they say approximate this number. Okay, that'll be the weird number. That's what we can't figure out. So what we're going to do is we're going to use the tangent line approximation at x equals 7. So that's our point of tangency. That's this guy right here. That'll be 7. And we'll use it to approximate 6.99, something very close by. And here's how we do it. So first we need to write the equation of the tangent line, which is y minus y1 equals mx minus x1. Nothing fancy going on yet, right? So we need two things. We need a point, which will be 7 comma f of 7, and then we'll need a slope. First, let's find our point. Plugging in 7, 3 times 7 is 21, minus 5 is 16, square root of 16 is 4. So that was pretty easy. We found our point. Next, let's find our slope. For the slope, I know I need to take the derivative, and we have a square root and then a complicated inside function. So we'll use the which rule? The chain rule. Try it yourself. Take the derivative of the outside, the square root. Keep the inside guy exactly where it is, and then multiply by the inside guy's derivative. So we know the derivative of square root x is 1 over 2 root x. So if it's square root monkey, the derivative is 1 over 2 root monkey, whatever that inside expression is. That's why I copied it down. Then we multiply by its derivative. So that's the chain rule in action. Next, we want the slope, though, at x equals 7. So we're finding f prime of 7, so I'll plug it in. That's going to be 1, or rather 3 on top, over 2 times, and we already did this. The square root of 3 times 7 minus 5, we found out was 4. So our slope at 7 is 3 over 8. Now we found our point right there, and our slope. We'll plug it in. We're getting now the equation of the green line. Please understand what's going on. Yeah, we found the point, we found the slope, we're writing the equation of a line. So y minus y1 equals m, the slope, that's 3/8, the derivative, at x minus the x value. Okay, so we did step 1. We found the equation of the tangent line, and now we're going to isolate f of x. So this is our f of x. So I want you to move the 4 to the other side, so we can get y by itself. And then plus 4. And in the last step, replace y with f of x. Now remember, we're finding an approximation. So in this step, I'm telling you rewrite y as f of x and also change the equal sign to be an approximation symbol. So whatever we want to find, in this case it's 6.99. We're always going to be finding an approximation. So on the AP exam, you need to have approximately, otherwise you will lose a point. So now we're going to plug in 6.99 into the equation of our line, like this. Is approximately 3/8 parentheses 6.99 minus 7 plus 4. Let's simplify the right side and we'll get our answer. So 3/8. Now 6.99 minus 7. Is that going to be negative 1? So first it's negative, right? Is that going to be negative 1, negative 0.1, or negative 0.01? Yeah, there's 2 decimal places, so you should choose negative 0.01. And now I want to convert this into a fraction. So in case you've forgotten how the fractions work, if I have 0.1, that's 1/10. If I have 0.01, 0.03, or rather, if I have 0.01, that's 1/100th. So if it's 0.01, it's 100th. If it's 0.1, it's a 10th. So then if I have 0.2, that's 2/10ths. And if I have 0.03, that's 3/100. Okay, so memorize these two guys. Very important. So watch why this is helpful. If I change that to -1/100, now I can use the fraction trick. So observe, this is going to be -3/800, and then plus 4, and I'll use now the fraction trick starting at the bottom. 800 times 4, that's 3,200. Minus 3 puts us at 3197/800, and guess what? That's our approximate value for f of 6.99. And I'm going to blow your minds now. Okay, I'm going to show you what we actually just did. So, we used, and we're done by the way. So we used this curve, square root of 3x minus 5. Let's see. The square root, come on, square root of 3x minus 5. And we plugged in 6.99 for x. So let's see what the real value is. If I delete that, and instead I put times 6.99, okay, you can see that the real value, the height of the graph, is 3.996248. Now let's see what our approximation was. 3197/800. 3197 divided by 800. Ah, look at that. It's super close. We got 3.99625. The real answer is 3.99628, blah, blah, blah. But if you round up right here, that 8, if you round up that 8, that turns this 4 into a 5, and we would have, like, we're close to 4 decimal places, you guys. It's pretty amazing what we were able to do here. So that's how the tangent line approximation works. It's pretty magical, very clever. Let's try another problem with it. By the way, this is our second to last problem of the day. So we want a tangent line approximation to this function. This is our anchoring point. We'll use it to find the equation of the line, and we're going to use that to estimate this weird decimal value. So let's try it. So anytime you see tangent line approximation, you need to find the equation of the tangent line. We need two things, a point and a slope. Find the point yourself. The point, use the x value they gave you and plug it in to find the y value. I got 2. Check if you also got 2. Now let's say I make a mistake, that's fine if I make a mistake at some point. Trust your algebra and just pay attention to the calculus. So that's our point. Now we need a slope. So slope, what's the symbols we use? We call that f prime to indicate the derivative. Okay, nothing but a simple power rule here. Straightforward. And then find the slope at the given x value. Check if you got the same slope as me. Pause the video if it's going too quickly and try to finish now the problem on your own completely. So we found our point. I'm going to highlight the information we found. And we found our slope. Let's create the equation. Now we'll do step 1. Write the equation of the line. Y minus y1 equals mx minus x1. Double negative, careful. Now remember, we want to isolate our y and change it to an f of x. So I'm going to add this 2 to the other side. I'm changing my y to f of x, and I'm also changing my equal sign to an approximation symbol. So we're done with step 1. Step 2 is just plug in your weird value now. into the equation of your tangent line. Whoops, that's a negative 0.9. So negative 0.9 plus 1 is 0.1. Convert that to a fraction. Should get 1 over 10. 8 times a tenth simplifies to 4 over 5 plus 2. Use the fraction trick. And we are done. F of negative 0.9 is approximately 14 over 5. Ta-da! Pretty cool. Okay, last problem. Now, this one says, find the linear approximation to f, but they're not giving us the function f. But that's okay, that's okay. We don't really need it. If it says find a linear approximation, we know that we're writing the equation of the tangent line. And so I know first, I always need a point and a slope. If you're clear on those concepts, then the problem isn't so scary. So we need a point. Have a look. Did they give us a point? Is it A or B? Which one's my point? A is the point, because it's f of x equals y. So that's my point, is negative 1 comma 2/3. That's your x value, that's your y value. And we need a slope. Well, I need the slope at negative 1. That's what this is giving me. The slope at negative 1 is negative 5. So I'm going to write f prime of negative 1, or, you know what, even easier, just write m equals negative 5. We know that's the slope. Ha! So they gave us everything. This is a super easy problem. So let's find the equation of that line. Look down and finish it yourself. Don't forget to get y by itself, and remember we're finding an approximation. Once we found our tangent line approximation, we plug in what they want us to estimate. So in this case, we're estimating f of 0. Therefore, we're plugging in 0 for x. Zero plus 1 is 1 times negative 5 is just negative 5 plus 2/3, fraction trick in the last step. And check if you got the same thing as I did. Make sure this says approximately for your final answer. Ta-da! Cool. I said it was the last problem of the day, but we're going to just finish up with a review problem, which is given here. It says find the slope of this function. Try it yourself. On the AP exam, you'd be given about 3 minutes for this max, okay, max. Actually, I would say 2.5. So why don't you time yourself right now for 2.5 minutes. Pause the video. Check when you're done. Okay, I'm going to start explaining now, so pause the video if you haven't already. Since I have an x here and I have an x here, I know these are two functions, therefore I use the product rule. However, if it was just 3e to the negative 4x, notice that 3 is not a function, it's just a constant. So then I would not use the product rule. I would simply say, oh, the derivative of that is just 3e to the negative 4x times negative 4. I would simply use the chain rule. And the 3 is a multiplier. But here the 3 is a function because it has an x squared with it. So we'll use the product rule. Copy the first. The derivative of the second, e to the negative 4x, that uses the chain rule because it's e to the monkey. So now times the derivative of that expression. Plus, now I'll copy the second expression and times by the derivative of the first. No chain rule here, that's just a basic power rule. Now in the last step, we're going to rewrite. So pulling negative 4 to the front, That gives me negative 12 x squared e to the negative 4x. And again, just good habits, put the monomial, the polynomial in front. Okay, last step, I'll be expecting you to factor this. So try it yourself. Look at the first expression and the second. What do they have in common? Start with the numbers. So we have a negative in front. We should take that out. And we could take out a 6 as well. Now we handled the numbers. Now look at the x's. X squared and x. So we can take out an x. E to the negative 4x, e to the negative 4x. It's identical. We'll take it all out. Open parentheses. Since we had two expressions here, we have two expressions on the inside. Try filling it in very carefully. Watch your signs. And check if you got the same thing as me. That would be my final answer. Whoops, just 2x minus 1 left inside the parentheses, and everything else was factored out. Ta-da! All right, we're done for today.